What is up, my dudes? It's Ryan with LEDgardener.com, and today we're going to be assembling our own HLG-480H-C2100B. This is a light that typically comes built from Horticulture Lighting Group, but if you have all the different components, you can save a few bucks and put it together yourself, and that's exactly what we're going to do today. The HLG-480 is a badass light. This thing is made up of 4 QB288 quantum boards, and they're run in series on a Meanwell HLG-480H-C2100 driver. In terms of coverage for this light, Horticulture Lighting Group recommends for vegging you can go up to a 6 foot by 6 foot space off of one HLG-480, and for flowering you can do up to 4.5 feet by 4.5 feet. So in a 4x4, which is probably the most common tent size that you see, this thing is excellent, and we're going to go over some PPFD measurements once I get this thing built. So let's get to it. Okay, so here are all the parts that I'm going to need for this little build, and the light that we build is not going to be a whole lot different than the one that you would get from HLG, with the exception of one major thing, which is the type of driver that I'm using. This is an HLG-480H-C2100B, and the B is the part that really sets it apart from what you would get pre-assembled. The light that you get from HLG is a C2100A, and the main difference is that you don't have that built-in potentiometer on the B like you would on the A, so you just use a screwdriver to adjust the current on that one. And another difference too is that with the A-type driver, you're able to adjust the current up higher than you can with a B-type. So the most you can get on a B-type with the pot all the way wide open is 2100 milliamps, which is obviously what this thing is named for. But if you get the C2100A, you can actually turn that pot up all the way to maybe 2400 milliamps. I've seen 2400 quite often. So that's a significant amount of power extra that you get on the A version compared to the B version. And that's why it's called the HLG-480, because with that A, you can actually get 550 watts out of it compared to 480 on the nose with the B type. So that's my driver. Over here we have the power connection for the AC side. I'm going to use this LLT L20 connector, which I really like. It's waterproof, it's got good strain relief. This is the AC cable that I'll be attaching to it. Run of the mill, 515. Here are a couple nuts and bolts. These guys attach the driver down onto this big heatsink. And then I have a whole shit whack of these little M3, I think they are, M3 screws. Over here are some aircraft cable hanger majiggers, and they have these little clasps that attach to each corner of the board, and then they all come together at a carabiner in the middle for like a single point hang. Don't really need to even describe these things. 4 QB288s, you all know what they are. These are 3000K. Here I have a little bundle of wire that I had just sort of kicking around. This is 18-2, so 18 gauge 2 conductor, and I'm going to use this to extend my potentiometer. So I'm just going to attach it onto my dimmer leads here, and then I'll have sort of a longer chunk to work with to put my pot somewhere. So here's the pot itself. This is a 100K ohm potentiometer. With it, I also have a little handy dandy fancy schmancy knob that you can throw on there. Wow, look at that. Now that's an improvement. That's beautiful, isn't it? And I also have a resistor with it. This is a 20K ohm resistor, and I'll show you why you might need one of these when we get into attaching that pot and looking at dimming. Also, I've got some red and black 18 gauge solid core wire. This is what I'm going to use to attach all the QBs together and then eventually attach back to the driver output, which is this guy right here, the blue and the brown. And I'm going to be using these Wagos to make that connection because they are awesome. Boom. So that's it. Those are all the components. Let's get started. My first step of assembly was attaching the driver onto the top of the heatsink, and there are a few holes drilled out for this conveniently on the heatsink. There's one big one, and that's where you're going to pass your wire through for your connection to the quantum boards, and then there are a couple other small ones that line up with the holes on the driver that are used for mounting. So you just kind of take a bolt, throw it in from the bottom, and then put a nut on top on each side, and nice and simple, you've got the driver on the heatsink. All you need is a screwdriver for this. You don't really need anything to hold the nut on top. If you can just use your fingers until it starts to tighten up, then you're able to snug it nicely with the screwdriver. With that driver firmly in place on the heatsink, the next thing that I tackled was terminating the AC power side. On this driver, you get 3 conductors. There's a green, a blue, and a brown on the AC side, and it's labeled right on top of the driver as to which one is which. Green is ground, blue is neutral, brown is hot, and I'm going to be using this LLT L20 connector, which is a nice waterproof connector that has good strain relief on it. You can get this thing from the HLG website, actually. They offer a kit with all these handy dandy little supplies in it, so this is a great way to terminate power. Out of the box, you'll find that the leads on the power side are a little bit too long for this connector to work nicely, because if you leave them that long, then the strain relief is going to clamp down on those 3 conductors and not the black jacket. So I shorten them up to a nice reasonable length and then restrip them. On these Meanwell drivers, you'll notice that all the leads are tinned, both on the AC side and the DC side, so they're covered in solder. And I've kind of wondered, is it better to solder these ends or not? Soldering keeps them nice and neat, it prevents stray wires and everything, but I've also read that if you have a soldered cable that's stranded, like this one, under a screw terminal, then the solder can kind of cold flow over time, and that is, it'll loosen itself up and it might become loose under that screw, which would be bad, right? But the majority of the research that I've done would suggest that leaving just the bare copper is better for a screw terminal. So that's what I'm going to do here. And really, I mean, like, if Meanwell's going to the bother of tinning all these leads, then it must be for a reason, and it probably wouldn't be so bad. And the chances of anything bad happening are probably very slim. And if I weren't trimming all these wires, then I would probably just leave the soldered end and connect that to whatever. But since I'm cutting them anyway, I'm not going to go to the bother myself of soldering them, and I'm just going to leave them raw copper. So once you've got the conductors shortened up and stripped, then you just put the collar over the black jacket and then fasten each one of the conductors into the screw terminals and make sure they're nice and tight and that there's no wire exposed. Moving on to the other half of the power connection, using the cable with the 3-prong plug and the green, black, and white conductors, I did the same thing. I just shortened up the conductors nicely, stripped them, and then I matched them up into the waterproof connector. So I have a black, a white, and a green. The black is going to be hot on this, so I match that to my brown of the driver. The white is neutral, which matches to the blue of the driver, and the green is ground, which matches to the green of the driver. This color code may not necessarily match the cable that you've got, so always be sure to double check and verify that you have all of your colors straight. While I have easy access to the driver connections, I'm going to terminate the potentiometer extension cable. We're not actually going to put the pod on it at this point, but we're going to strip back the cable and then using Wagos connect to the 2 dimmer leads on the driver, which in this case are gray and black. And with the Wagos in place, I'm ready to terminate the other end of the cable when we get to that part. At this point, it was time to turn the heatsink over and start putting the quantum boards on it. And if you just kind of slap the boards on willy-nilly, then you're going to end up with some weird wiring. So it does pay off if you put in a little bit of time and thought as to how you're going to lay these things out. This is how I laid mine out. On this diagram, that little black circle you see, that's the hole that I'm going to pass my cable through from the driver on the top of the heatsink down into the quantum board area below. And this is a good place to start wiring. So right off the bat, what I'm going to do is take the positive from the driver and connect that into the positive input on the top right quantum board, and then take the negative from the driver and connect that into the negative input on the bottom right quantum board. And once this connection to the driver is made, both positive and negative, all we have left to do is make series connections to the rest of the boards until the loop is complete. So what does that look like? I'll use little blue cables, and since we're going into the positive on the top right board, that leaves us coming out on the negative of that board. So we go negative of the top right into the positive of the top left, right? Series wiring is negative to positive or positive to negative, however you want to view it. So we've come in on the positive on the top left. We're going to go out the negative into the positive of the bottom left. And then all we have left to do is go out the negative on the bottom left into the positive on the bottom right. And now our loop is complete. If you're going to be putting a whole bunch of quantum boards in, or you're moving them around quite often or something, I would suggest using a drill instead of a screwdriver. Using a screwdriver is going to get old real quick. And just be careful when you're putting these things in. Don't really impact them in there. I just kind of get them to the point where they're all tight and the boards are in place, and then I go around with the screwdriver and just put the finishing touches on every screw and snug them up. With all the boards secured and in place, it was time to put the wiring in that I had planned for in my diagram. And the great thing about series wiring is that there's so little of it that you have to do. Really, aside from the connection to the driver, we have 3 little chunks of cable that we need to put in. So all I did was take 18 gauge solid core wire and strip off just a bit off the end, making sure that I didn't take too much, because you don't want any bare copper that's exposed, right? The bit that you strip off should all be hidden inside each connector, so don't get too overzealous with your strippers. On my last 2 connections for positive and negative to the driver, I took my 2 conductors and twisted them together to make them all purdy-like, and then just fired them back through that hole, and they were ready to connect via Wagos on the other side to the driver leads. Making the connection with the Wagos is really simple. There's nothing special about it. You might have to strip just a little bit more off of each of the conductors so that they get all the way into the connector and there's a good bite on them. But once you use these things for the first time, you'll realize what a breeze they are and how nice they are to work with. In the interest of keeping things somewhat neat, I used a tie wrap to keep all these wires together. So I bundled up the output of the driver, the AC side, and the pot wire as well, and then just put a little tie wrap on them to keep them kind of sucked together so they're not going to flop all over the place. The only connection that we have left to make to the driver at this point is the potentiometer, and we've already connected our little extension cable to the dimmer leads of the driver using Wagos, so now all we need to do is connect the potentiometer to the end of the extension cable. As I had mentioned earlier, if you get a potentiometer as part of a kit, like you might with the Horticulture Lighting Group accessories kit, then you may get a resistor with it, and you're probably wondering, what the hell am I supposed to do with this resistor? So I'm going to crack up my multimeter, and I'll show you exactly why you might need one of these things. If you're using a potentiometer in conjunction with a Meanwell HLG series, which is what pretty much everybody is using for this application, then you're going to need a pot with a maximum resistance of at least 100k ohms. And that's important because that driver requires at least 100k ohms to put out full power. If your pot isn't going that high, then you're never going to get full output from your driver. And the shitty thing is, with cheaper pots, there's a lot of variability in that actual resistance of it. So usually there's a 20% tolerance on that. So on a 100k ohm pot, it could be anywhere from 80k ohms to 120k ohms. So sometimes you need to use a resistor in conjunction with the pot, just wired in series, to make sure that your max resistance is actually exceeding 100k ohms. I had a couple potentiometers kicking around. Both of them were rated for 100k, and I found that the first one went up to 108k, so that's fine. I could use this just straight up connected to the dimmer leads and I'd be okay. But the second one that I measured was actually coming in at 88k ohms, and that's no good to me. So in this case, we would need to add one of the resistors that we have in order to hit that 100% output. Just to see the difference that the resistor makes, I've rigged it up here in series with the potentiometer and the black lead of my multimeter. So the resistor itself is rated for 20k ohms, but the same rules apply, and it's actually about 18k. But when you add 18k to the 88k of the pot, then you get 106k ohms. And now we're rocking, right? We have over 100k ohms, so we're going to get that max output from that driver that we wouldn't have had otherwise. So how do you incorporate your resistor with your potentiometer? Well, it's really easy. All you need to do is put this resistor in series between your driver dimmer lead, and it doesn't matter which one, and the solder lug on the potentiometer. I've determined that I want to use the left and the center pins on the potentiometer. You'll see that there are 3, and this would be the most common configuration, I'm sure. If you go left and center on this one at least, when you turn the pot all the way clockwise, that means that it's going to be outputting full power, and then all the way counterclockwise would be the minimum power. If you go right and center, then this would just be reversed. Here I'm prepping my extension cable for the resistor and eventually the potentiometer connection. I'm going to put it on the red side. It doesn't really matter at all which side you connect the resistor to, but in this case I'm cutting the red conductor shorter than the black conductor because I'm going to have that added length of the resistor on there as well, and I'll also have some heat shrink over each of these connections. To attach the resistor, all you need to do is twist it onto the bare copper of your extension cable, and then you can trim off any excess part of the resistor that you're not going to need just to keep it clean, and you're ready to solder them together. Once you've soldered this side of the resistor, then you can trim the other side to keep it a little shorter for the solder lug, and make sure to throw your heat shrink over top before you solder it onto the pot, or else you're screwed. The nice thing about getting a potentiometer with the solder lug termination is that you can use them to twist the resistor into, and then it will stay there as you solder it. You don't have to hold it or pinch it in there somehow. So just take the end of the resistor and then sort of wind it into place and solder that, and then you're ready to heat shrink the connection so it's nice and covered and protected. And then do the same in the middle on the black conductor, and then you're basically all set. Your potentiometer is terminated. All you need to do is throw that fancy schmancy knob on it, and you're rocking. To hang this thing, all you need to do is connect up the hangers into the pre-drilled holes in the corners, and I'm only using a single point hang, so everything kind of comes together at the carabiner in the middle, and that's probably just about at the limit for the single ratchet strap that I'm using. You should probably use two, but I only had one handy, and I'm only going to be testing PPFD briefly, so we're just going to do a single point hang. But this assembly is actually pretty heavy by the time it's completely built. The thing weighs about 17 pounds. With the light completely assembled, it's time to test it, and the first thing I want to check is the voltage and the current. With the potentiometer turned all the way up, I was getting a current of 2.099 amps, so just about true to the 2.1 rating of the driver, and 214 volts, which works out to about 53.5 volts per quantum board. In terms of temperature, I let the light run overnight, and then in the morning I checked it with my Fluke thermometer, and in the hottest spots on the back of the heatsink, like pretty much right center of where the boards would be beneath it, I was getting temperatures in Celsius of mid-60s roughly, which is getting kind of warm, but still reasonable for this amount of power and this amount of space, so no real issues here. Moving on to PPFD, I did my testing in a 4x4 tent because I think this is going to be the most common use case for this light, and as always I did my measurements at 18 inches and 24 inches, and here's what I ended up with. I'm going to bombard you with a whole bunch of data here. I have my results for 18 inches on the left and 24 inches on the right, and for both of these tests I was using this HLG-480H-C2100B, and it was measured at 449 watts. Let's focus first on the 18-inch results on the left. If you look right in the center on the first square foot, you're going to see that most of these values are above 1,000 micromoles per meter squared per second. And that's a lot of light. Like, that's sort of the upper limit as to how much light that most people can use until you start doing things like supplementing with CO2. So 1,000 is borderline excessive, anything above that really. So you get kind of a hot spot if you have the light this low right in the middle. And as you move out into a 2x2, you're sort of getting more reasonable numbers between maybe 600 and 750 micromoles. Those are good levels. And then bumping out to a 3x3, it's still holding pretty steady. We're looking at 350 roughly in the corners and mid 500s or so around the edges, like in the center of the top and bottom and left and right. So really good numbers, very strong throughout a 3x3, and they tend to hold pretty well into the 4x4 as well, except for the very corners. But looking at the centers on the tops, bottoms, lefts, and rights, you're still in the 400s for most of these measurements, which is excellent. Like, to push all the way out to the edge of a 4x4 with this one single light fixture is really good, and keep it near 500. That's great. You do see a little bit of a drop-off in the corners, which is always bound to happen with something like this where you've got a main fixture in the middle of the grow space. And I've heard of people that are actually using cobs in the corners to sort of bridge the gap and keep a really nice and uniform coverage across the whole thing. And I think that's a fantastic idea. You see these little corner circles on the 3x3 outline in the diagram, 340, 370, 330, 360. If you plopped a cob in each one of those corners and ran it fairly low power, say 50 watts or even less maybe, then you could end up with some really nice and smooth coverage right out to the corners of a 4x4. And for those of you that are hell-bent on perfection and want a completely even canopy, this might be a good idea. It'll be some extra work and some extra money, but it might make sense to you. However, for most cases, I think it's fine without them. The coverage is just fine from the light itself, and it'll drop off a little bit, but who cares, right? Your plants will not be hiding only in those corners, so things will be good. Moving on from that little tangent, let's look at the 24-inch results. At 24 inches, you're definitely losing that hot spot in the middle. You're going from 1,000 plus down into the mid 700s in the first square foot or so. But the cool thing is, you're not really losing a whole lot out further, like if you look right on the perimeter of a 4x4, the numbers are the same in most places or better. And I think that's just because of the angle of the light coming off of that fixture. It's a little bit tight at 18 inches, but as you lift it higher, you're getting a little better coverage. So 24 inches, it seems like actually a pretty good height for this thing in most cases to me. And with the exception of the hotspot in the middle that we've ditched, most of these numbers are very comparable to 18 inches, so maybe 24 inches is a sweet spot for this fixture in a 4x4. One more thing to keep in mind is that this isn't a perfect representation of what the actual HLG-480 can do, and I mean the one that's pre-built from Horticulture Lighting Group. And that's because, again, this is a B-type driver, so we're maxed out at 2100 milliamps of drive current. And with the A-type, you can get up to 2400 milliamps of drive current. So that works out to maybe 10 or 15 watts more per quantum board. So you can expect these numbers to increase a little bit, not a whole lot really, but a little bit if you were to use the actual HLG-480. Alright, that's going to do it for this video. Thank you everybody for watching, and thank you as always to the boys at Horticulture Lighting Group for hooking me up with this gear to play with and to test. And please, if you like what you see, hit that sub button and stick around. I've got a lot of really good content planned for the near future. And you know, I'll let you in on a little secret. I think the next review style video that I'm going to do is going to examine the HLG QB120, which is the new vegging quantum board. I have a 65 watt kit sitting here in front of me, and I'm just itching to get this thing tested. So stick around for that and a lot more, and we'll see you next time.